Chapter 8 is going to be about quadratics again and different types of solving quadratics. And some of this you probably have seen, some of this you have not. And depending on your Algebra 1 teacher, you may have seen completing the square before, you may not have. So before we get started into what completing the square is and how to do that, it says what term would you add to the following polynomials to make them perfect square trinomials? So quickly, let's think about, remember what a perfect square trinomial is. So perfect square trinomial comes from us being able to take a binomial and squaring it. And so that is equal to what? That's equal to a squared plus 2ab plus b squared. So we need to figure out what is it that we are going to, figure out what can I add to this to make it a perfect square trinomial. And so what you're going to want to do here is think about that. So what number do I want to be here in order to squaring it and then doubling it with 1 that gets me 4? And, so you might be able to think, okay, that's going to be a 4. Well, why is that? And here's just a kind of a shortcut, is that you take this middle term, the one attached to the x, and divide by 2, and you get 2, right? So you're going to take and square that number. So this is going to be 2 squared, which then is equal to that 4. So if you think of this is x squared plus 4x plus 4. If I factor that, then I have a perfect square trinomial, because that factors to that, correct? So again, it's quick to just take this number here, it's attached to the x, half it, and then square it. That's going to give you that perfect square trinomial. So down here, x squared minus 6x. So again, what is it that I need to add to make that a perfect square trinomial? So divide by 2 here, you get a negative 3, and negative 3 squared is 9. So you're going to add 9 to that. This is going to be important because this is where we're going with completing the square. Here's a fraction, but you can still do it with a fraction. So you're still going to take 2/3, divide by 2. And so 2/3 divided by 2 is 1/3, right? And then when you square that, you're going to add that to make it a perfect square trinomial. So this is 1/9. Now, I know some of you are probably thinking, well, you just can't add things to make it, to keep it equivalent, because they're really not equivalent. You're right, we can't. But the question says, what would I add? And so that's where we're heading into in this next slide. So now let's just go right into solving quadratic equations by completing the square. And what I'm going to do over on the left here is I'm going to kind of write the steps as we go so that you can see what it is that we need to do to complete the square here. Completing the square is actually one of my favorite things to do. I think it's pretty easy. So the first step in completing the square, when you're what you're trying to do is you're going to try to create a square so that you can square both sides, solve by square rooting both sides. So the first thing you're going to want to do is make sure leading coefficient is 1. Okay, so look at then remember, leading coefficient is what's attached to the x squared. So is this a 1? It is, right? So I don't have to do anything. So this one I wouldn't have to do that first step. So now the second step is do what we just, well, first we're going to move the constant. So if you look at this problem, x squared minus 8x plus 1, you want to take this constant here and you want to get it to the other side. So we're going to move the constant to opposite side. And I guess really what I should say there is make sure that you have x squared and x on one side and x and the constant on the other side by itself. So move the constant to other side. Okay, that would be my step 2. So in this case, I'm going to subtract it. So I'm going to get x squared minus 8x is equal to a negative 1. Okay, so now we're going to do what we just did on that previous slide, and that we're going to take half of that number, negative 8, and we're going to add it to both sides so that we can make this a perfect square trinomial. This we were allowed to do it because we're going to be doing it to both sides. So the third step here is half the middle term and that would be the coefficient is on the x. So the coefficient on x. Right? So you're going to half that, and then you're going to square it and add to both sides. No matter what you do, you're adding it, okay? So don't let that throw you off. It should say sides there. So add. That's the key thing here. I mean, in half it. So -8 divided by 2, you get a -4. And now square that. So that is what you're going to put in this spot right here. So you're going to put a -4 squared and a -4 squared on this side. And since I'm doing it to both sides, I'm allowed to do that. This part over here, this right here, can simplify to x squared minus 8x plus 16, correct? And this side over here, -1 plus 16 becomes 15. So that's a more simplified equation now. The fourth step in this process now is to factor the quadratic. Okay, if you can't, then you didn't do something correctly. So up here, this is my quadratic here, right? So we're gonna factor that. So what do we factor that to? Well, that's a perfect square trinomial, and it should factor to x minus 4 squared. Because that's what you just created it to be. So the -4, whatever this number here is, whatever you got as the half, that is going to go there, and then x squared, okay, equals 15. And now you're just going to solve this by square rooting both sides. So the fifth step is to solve. Do not forget plus minus. Okay, so coming over here, I square root both sides. So if I square root both sides here, I'm going to get x minus 4 is equal to plus or minus root 15. And now just continuing to solve. So x then is equal to 4 plus or minus root 15. I just like to put the number out in front just to keep it with a real number first. It does not matter. And so what does that mean? That means that my solution to this this equation, x squared minus 8x plus 1, is a positive 4 plus root 15 and a 4 minus root 15 because it's a plus minus. So both of those are the solutions to this equation. Let's do another example. So x squared plus 6x equals 16. So this one already has the constant on its side. It already has a coefficient of 1, so we can go straight to squaring and adding. So you're going to take that positive 6 and divide by 2 and get 3. So that means your next step is you're going to add 9 to both sides because that's the 3 squared. So you're going to add 9 to both sides. And x squared, now we're going to factor this. So x plus, because it's already, we can factor and simplify at the same time. This is going to be x plus 3 squared equals 16 plus 9 is 25. Take the square root of both sides, square root. So you get x plus 3 is equal to plus or minus, don't forget that plus or minus, the square root of 25. Well, we know what the square root of 25 is, right? That's plus or minus 5. And so then you subtract that 3, you're going to get a -3 plus or minus 5. Well, you can actually simplify that further, right? So you can do x is equal to a -3 plus 5, and x is equal to a -3 minus 5. You do not have to write this stuff out, but I'm just showing you. So x is equal to 2, and x is equal to a -8. And so that has a solution set of 2 and -8. Next one here does not have a leading coefficient of 1, and it does not have it in the order that we need it. So we're going to have to rearrange this. First thing I'm going to do is get rid of that 1/2 to get this 1/2 off of here. So what am I going to do? I'm going to actually multiply everything by 2 to get that 1/2 to go away, correct? So I'm going to multiply everything by 2. So these 2's cancel, so you're left with an x squared plus 6 equals 10x. But I need the x squares. I need these two to switch places, right? Because I need the x with the x squared. And so by doing that, I'm going to subtract the 10x over. I'm going to subtract the 6 over. Now it's in a situation that I want it. So I'm going to take that middle term, -10 divided by 2. I get a -5. Square it. So I'm going to add 25 to both sides. Now I'm going to factor. So factoring this here, this is going to become x minus 5 quantity squared. And negative 6 plus 25 you get is 19. Square both sides, square root both sides, you're going to get x minus 5 is equal to plus or minus root 19. And then you're going to add the 5. So x is equal to 5 plus or minus root 19. I failed to mention on this one here, if this one comes down to two integers, that means it's factorable to begin with. And so you could have just factored this, but you could also do completing the square. In this case, these are irrational. And so since you've got irrational numbers, so my answer to this is 5 plus root 19 and 5 minus root 19. Those are my answers to that. Number 4, you're going to end up getting some fractions. It's not going to be as pretty, but you still can do this one. And so you're going to divide everything by 6 to get that constant of coefficient of 1. So you get x squared minus 7 6x is equal to 5 6. And so same thing. You're going to take this here, and you're going to divide it by 2. So negative 7 6 divided by 2 is actually negative 7 twelfths. And then if you square that, negative 7 squared is 49. 12 squared is 144. So you're going to actually add 49 over 144 to both sides. And this is looking ugly, okay, but it's all right. So then this factors to x minus 7 twelfths quantity squared. And then 5 6 plus 49 144s, well, you could convert those to the same denominator. So 5 6 in 144s, what is that, 120? Yeah, 120 144s, and then plus 1 or 49 144s. And then adding those, you're going to get 169 144s. So that side becomes 169 144s. Square root both sides. You get x minus 7 twelfths is equal to plus or minus, don't forget those, 13 twelfths, right? Because square root of 169 is 13. Square root of 144 is 12. Add the 7 twelfths over. So you're going to have 7 twelfths plus or minus 13 twelfths. See how convenient that is. And then to find your, to finish your problem, you're going to do x is equal to 7 twelfths plus 13 twelfths, and x is equal to 7 twelfths minus 13 twelfths. So 7 twelfths plus 13 twelfths, plus 13 twelfths is 20 twelfths. And 20 twelfths is the same thing as 5 thirds. And 7 twelfths minus 13 twelfths is a negative 6 twelfths, which is the same thing as a negative a half. So my answer to this is 5 thirds and negative a half. Again, they're not irrational numbers. This was actually factorable as well. But that's okay. You know, we can do it anyway. This one here is going to be a little different to see what happens here. Same thing though. Divide by 3, divide by 3, divide by 3. So you're going to get x squared plus 4 thirds x plus 5 equals 0, right? And then now bring that 5 over, so you're going to get x squared plus 4 thirds x equals a negative 5. And then now you're going to take that 4 thirds and half it. So 4 thirds divided by 2 is 2 thirds, right? So this comes out to be 2 thirds. Square it, you're going to add 4 ninths to both sides. And now factor it. So this becomes x plus 2 thirds quantity squared equals negative 5 in ninths is negative 45. Negative 45 plus 4 is a negative 41 ninths. Square root both sides, square root both sides. So you're going to get x plus 2 thirds is equal to plus or minus the square root of negative 41 ninths. Well, we already know how to deal with this, so right? So we could write this as x plus 2 thirds is equal to plus or minus I root 41 over, and the square root of 9 is 3. So we can write it that way. And now subtract the 2 thirds. So negative 2/3 plus or minus I root 41 over 3. And that's, you could write that is your answer, or you can separate it in saying that it's a negative 2/3 plus I root 41 over 3 and a negative 2/3 minus I root 41 over 3. I don't care if you leave your answer this way up here. Like, you can leave your answer like this in the brackets. That's perfectly fine. Or you can separate them. But if they come out like this, you do have to separate them. But this way you don't have to. And then the last example, w is equal to the square root of w plus 1 equals over 2. Radical equations, you're going to, solve this the same way. So you're going to, that you're used to. So you're going to multiply by 2. So you're going to get root w plus 1, right, over there. Now you're going to square both sides. So you get 4w squared is equal to w plus 1. That stuff there should not be unfamiliar to you. Now you're going to put this as 4w squared minus w minus 1. But as you can see, that it's not factorable. So I'm just going to leave it like that. But now I have to divide out that 4, because now you're going to have to solve this, and you can't factor it. So let's complete the square. So divide by 4, divide by 4. Some of you know the quadratic formula, but right now we're not doing quadratic formula, so we're just going to complete the square here. So we have w squared minus 1/4 w is equal to 1/4. Now I'm just back to what we were doing. 1/4 divided by 2, a negative 1/4 divided by 2 is a negative 1/8. Negative 1/8 squared is 1/64. So you're going to add 1/64 to both sides. So this here then becomes w minus 1/8 quantity squared is equal to, well, 1/4 plus 1/64. 1/4 is 16/64. So 16 plus 1 is 17/64. Again, you can't do those in your head, then do them on a calculator. That's perfectly fine. Now we're going to square root both sides. So you get negative w minus 1/8 is equal to plus or minus the square root of 17/64. And so w is equal to 1/8 plus or minus, and then 17 is not simplifiable, but root 64 is the same thing as that. All right? And now here's the tricky part with this type of problem is you've got a square root. That means you've got to check these answers to make sure you're not getting an extraneous root. You're going to have to say, okay, w is equal to 1/8. I would take it to a decimal and then use that as a plugging in it. So this is going to be approximately, if you type this into your calculator, I think you get it 0.6403. Now, you're going to want to do a little bit more than that to store it, because you can store. Remember, you can type this answer, hit enter, it's going to give you a decimal, and then do store A, or wherever you want to do it. Then check it. So if you plug that back in up here, 0.6043 equals 0.6403 plus 1 divided by 2, you actually get that this one does check. Now, if you're going to use a rounded answer, you might have to look at a little bit at the decimals. Okay, you might not get exact, but it's probably going to be very, very, very close. And then the next one, you would do 1/8 minus root 17 over 8, which, again, if you type that into your calculator, you're going to get approximately 0.904. And again, store, I wouldn't round it, I would just store it, and then an A, plug it back in. And you do not get, you get actually a negative answer equals to a positive, so this one does not work. And so your solution to this then is, and make sure you're checking that you know how to use this calculator to check these answers. Your solution to this would be 0.6403. Okay? Go ahead and do the true false. We'll go over these and we will answer any other questions that you may have. Have a good evening.